welcome to this video. Here we'll be learning about simultaneous equations on a graph and using the discriminant to distinguish how many solutions there are. Okay, so I will show you how to use your graphic calculator if you have one in a separate video. But if you had to use a graph to solve the simultaneous equations, I must say there are rarely these kind of questions in exam. So all you would have to do is draw two linear graphs and find the intersection point. Now, how would you plot this first equation on the graph and second equation on the graph? You say, then if I want to know the y-intercept, I substitute x equals to 0 in this equation here. So x equal to 0, when you substitute it into 1, you get 3y equals to 10. Therefore, y is 10 over 3. So the y-intercept is 3.3 recurring, somewhere here. Alright, so let's just say 3.3 recurring. And to find the x-intercept, you substitute y equals to 0 into equation 1. When y is 0, 2x is 10, so 1x is 10 over 2, which is 5. Therefore, it would go through these points. Once you know the x and y intercept, get your ruler and you join them with a straight line. Now, your straight line is better than my straight lines because you will use a ruler. Now, we've plotted graph for equation 1 there. To do the same thing for second equation, you say to find the y-intercept, you substitute x equals to 0. So this will give you y-intercept. When x equals to 0, equation 2 is negative y equals to 4. Therefore, y is minus 4. So it will have some sort of intercept down here, minus 4. Now to find the x-intercept, you say let's substitute y equal to 0 into equation 2. So when y is 0, 3x equals to 4. Therefore x will be 4 over 3. 4 over 3 is 1.1 and 1/3, so that's somewhere over here. 1 and 1/3, you can write this 4 over 3. Now you see that if I draw this with a different color, that might help. So this is for equation 2 here. So this value is so when I said minus 4 is down here, so I'm going to use that, and 4/3 is here. So when I join these 2 points with a straight line, I can just carry on with that straight line with the ruler. Okay, so the intersection point is somewhere here. Now, if your graph is accurate, you can actually read it from the x and y axis. Okay, so the x coordinate of the intersection point is there, and so on. So this is what we did to figure out the intercepts. You join the intercepts with each other, and you end up with this situation. So, alright, then you find the intersection point from the units on the graph. As it turns out, it's 0.2, so this point x and y value are both 2. Alright, so in this next equation, you have a straight line and a quadratic. Once again, you need a table of values to plot these quadratic and straight line. So once you've plotted them, with the linear line, you can just use x and y intercepts. You substitute x equal to 0 and y will be 3, and y equal to 0 gives us x is 3 over 2. So then you just plot them and join those intercepts with each other. It will be a straight line. Then you need a table of values for the coordinates of quadratic, which you get as such, and you find the intersection point and you would read it. Now I can show you with a graphic calculator how to find intersection points on a graphic calculator and how to plot these graphs on a graphic calculator. I'll do that in another video, next video perhaps. Alright, for now, we've got more important things to learn. We are going to go back to what we learned in a previous chapter about the discriminant. If you remember, in chapter 2, we looked at the quadratic formula and we said what's under the square root is known as the discriminant, isn't it? So what what we're going to do is have a more in-depth look at the discriminant. When the discriminant was positive, we said we will get two distinct roots for the equation. Distinct uh, roots means that they have they will be they will be actual real values. So it has two solutions with x equals to 0. You can think of it as number of solutions really. So and we went through these different examples. When the discriminant was exactly equal to 0, it would the x-axis would be tangent to the curve, and if the discriminant is negative, there is no intersection point, so there is no solution. And it doesn't matter; it's exactly the same. Uh, the inequalities don't change. If your graph is inverted quadratic, that's this. These are exactly the same as above. There's one solution when the discriminant is equal to 0, there is two solutions when the discriminant is positive, and there is no solution when the discriminant is negative. Now, we are not, we don't have this kind of, how do we know that our equation isn't as neat as just a number in front of x squared and b c is in this chapter here, our equations aren't so neat. For example, in previous chapter we just had really nice straightforward equations where 2x plus 3x 2x squared plus 3x plus I don't know, 2 is equals to 0. You would have to find whether this equation has one solution, no solution, or two, or how many. That was easy to substitute. But as we've seen already, if you watched my previous video, we went through the part A of these two questions and we had to drive some weird quadratic formula. Now, I say weird because reading the A, B, and C values is a little bit tricky. If you look carefully here, yes, value of A here is 2, that's nice. Value of B here is actually negative of this bracket here. So you have to be careful. B is actually minus 2k minus 2, right? And value of C also is a combination of a constant. So C is actually 3k minus 1. So in the next few examples, we'll be working with equations. Now you actually have to substitute these values into the discriminant. Now the discriminant is just b squared minus 4ac. So you don't need to worry about the quadratic formula. We're not dealing with the entire formula. We're just looking to substitute these values into the discriminant to figure out whether there is one solution, two solution, or no solution at all. Once again, let's look at down here for to see what's the actual value of A, B, and C here. All right. So value of A is the coefficient of x squared, which is k. Value of B is minus 2 because there's only negative 2x there. Right, so I'm going to write minus 2. But the value of C is actually 3k minus 2. So get used to the idea of reading A, B, and C in exam situation from some weird looking quadratic equation. Okay, so the question was actually helpful to us because whether you knew it or not, it told you what the quadratic equation will look like, and part A, you just had to prove it. So show that it was a show that kind of question where you already know the answer and you're working towards showing the algebraic proof for it. So this is a nice example, and so was this. It was another show that question because you know what the answer should be, but you just have to show the algebraic formula for it. All right, so let's just review what we learned. We said that when b squared minus 4c is positive, we will get two solutions. So in real examples, we will get like a linear line with a quadratic. So this is where it's we're not finding the solution between the quadratic and x-axis. We're finding the solution between a quadratic and a linear line, which is a slant and has a intercept and a gradient. And when we said this discriminant is exactly equal to zero, there's just one intersection point. So you might want to learn the word tangent here. When they say this line, the straight line is tangent to the curve, what they mean is that there is tangent is only distinct one distinct solution. Okay, so make sure you remember this word tangent. All right, means that there is only one solution to the problem, to the quadratic equation linear simultaneous problem. All right, and when there is no intersection point, the tangent doesn't. There is no tangent. The graphs don't intersect. All right, they don't touch each other. So the discriminant is negative. All right. So let's look at an example here. We've been told that the line y equals 2x plus 1, this is linear one, meets the curve with this equation at exactly one point. Now they could have been nasty to us and say it's just a tangent to this curve. That means it will meet at exactly one point. Given that k is positive constant, find the value of k, and for part B we will consider some other work. Let's just focus on part A. So the fact that we know it's exactly one intersection point is telling us that the discriminant b squared minus 4ac has to exactly equal to 0. So we just need to look carefully at this equation here and think carefully what is the a, b, and c. Now y and x are this is kind of equation that's not even a quadratic yet. We need to replace this y, get rid of that y with substitution here first to make it all in terms of at least one variable. K is a constant, we're not calling k a variable. The x and y are variables, so it needs to be in one variable. Okay, so I'm just going to make a note for you. You see a quadratic equation's got x and y in it, needs to be in one variable only. Alright, variable is x's and y's, things that change. Alright, so first we're going to substitute, replace y with 2x plus 1. So let's rewrite the equation here. I'm just going to label it equation 1. And we're going to call the linear line equation 2. Alright, so kx squared plus 2, I'm going to open a bracket and leave a gap there and write plus, and I left the gap for this y, so I'm here now, plus k minus 2. Now they put the bracket around k minus 2 just to give you a hint anyway. So now I know the equation of linear line is 2x plus 1. I'm going to write 2x plus 1 where the y was originally. Now I'm going to expand the bracket and rewrite this equation. This is equation 1. So kx squared plus 4x plus 2 plus k minus 2. Now I'm going to drop that bracket here because what you see is this cancellation. This plus 2 and minus 2 will cancel away anyway. So now if I rewrite equation 1 again, I have kx squared plus 4x plus k equals to, why am I writing equal to 0? Uh, because that equation is 0. Alright, so this is equation 1. I'll just rearrange the equation 1. Now, if I change my pen color, that might help. So this discriminant b square is talking about the b value here. So I'm going to write b equals to 4, and then I'm going to write what's a. Our a equals to k here. So, and our c is also equals to k. Alright, so now I'm going to write the discriminant with get different color. So I'm going to write discriminant. The equation for discriminant is b square, which is 4 square, minus 4 lots of ac. It might help if you write the equation before you substitute into it. So, alright, so that's b square for a is k, so I'm going to put k in this bracket, and c is k. I'm going to put c into that other bracket. So expand this, and we know why is this equation equal to 0? Because they told us that there is only exactly one point of intersection. That's why we're setting this discriminant equal to 0. It could have been less than 0, it could have been bigger than 0, but we know that it will be exactly 0. Now solving for k, we got 16 minus 4k squared equals to 0. Take 4k squared to the other side, so we'll get 4k squared equals to 16. So for k, divide by 4, we get k squared is 4, therefore k can be positive and negative too, but they told us somewhere, did they not say k is positive? Yes. This question says k is positive constant, so I'm not going to write minus 2. I should, in general, every time you take the square root, you write plus or minus on both on the answer, but I'm just going to leave the minus sign out. Now I know k is 2. I've answered part A. Now let's read part B. It says for this value of k, find the coordinate of the point of intersection. Alright, so I'm sure about this value of k is 2. I go back into the equation and I can solve it if I know the value of k. What equation? This is equation 1, what we started with here. This equation 1, I can just rewrite this version of, which is already eliminated y. We went through all the working out and eliminated y. So it's nice and neat and ready to be solved. So 2x squared plus 4x plus 2 must equal to 0. Now trying to solve this equation for x, I'm going to take 2 and multiply that by other 2. I'm going to rewrite it. This is not an official method, but it works, and I know that in the end I just need to divide by 2. Factorizing this, I'll get x plus 2 and x plus 2 inside the brackets. Now, because here I remove the 2 and multiply by this last term, I need to divide by 2, divide by 2. So in fact, I'll end up with x plus 1 and x plus 1 inside the brackets. Once I know there is, yeah, and this is telling us, look how fascinating, that there is only x equals to minus 1. There's a repeated root in our equation. So when it's repeated, we know that there's only one intersection point, and that is where x is equals to minus 1. We can figure out y is as well with the linear line. Now I'm going to use equation 2 here and say y is 2 open bracket minus 1 plus 1, and minus 2 plus 1 is minus 1. So the coordinate of intersection point is minus 1 minus 1. Alright, Okay, I don't think there's another example, but I've made up. Well, I've added a couple of more questions, so you get a little bit more practice. Let's look at them in the next couple of examples. All right. If you remember from last video, we went through part A of the problem, and we did prove and show that part A was true. Sorry. All right. So we already if you don't remember, go back and watch the last video. We went through the part A and we've shown this already, so I'm not going to go showing this equation is true. Now in part B of this problem is saying that line L has two distinct points of intersection with curve C. Alright, so this is the combination of this weird quadratic equation is a combination of setting the curve equals to the line, and we rearrange those formula, those two there, we rearrange it to get one equation here. Now, because we have two distinct points of intersection, what does that tell us? This is telling us b squared minus 4ac must be strictly positive. Alright, so we're gonna look for a, b, and c in this weird looking quadratic equation. A is k, the value of b is minus 2, and value of c is 3k minus 2. So we need to work with these red values that I'm writing here. Forget about those two equations. They are here. They are here. So now I'm substituting for b. So b squared is minus 2 b squared minus 4 times value of k, which is a is k, and c is 3k minus 2. And I'm gonna write inequality sign as it is because I know it must be bigger than 0. So let's work it out. 4. Now leave the coefficient of 4 alone. Let's just multiply the k into this bracket. Get 3k squared minus 2k. On the next line, I multiply the minus 4 into this equation, and I get 4 minus 12k squared. Minus 4 times minus 2 is minus 8k, is bigger than 0. Now, it's not looking so nice and neat as we want it to be, but we can do some manipulation. You see, every coefficient here is a factor of 4. So, or is a multiple of 4, my bad. So we can factor 4 out of them, and what we end up with, actually let's factor a minus 4 out of them. So if I put minus 4 here, and I'm going to take the k squared coefficient, end up with 3k squared. If I factor negative 4 out of minus 8, I end up with a plus 2k. And if I factor minus 4 there, I will have minus 1 here. Alright, so this inequality is true. We can divide both sides of inequality by a negative number, which I was gonna show you in the next video. When you divide or multiply by a negative number, this minus 4 at the front, when we multiply or divide with a negative number, what's gonna happen to inequality? Can I leave it as it is? No, it will flip. Okay, flip. Okay, flip the inequality sign when you divide or multiply by a negative number. Now, I had another slide to show you why. Because let's take minus 3, which is less than minus 1, for example. If I multiply both sides of, or by a negative 1 here, I'm multiplying both. This inequality is true, right? Minus 3 is less than minus 1 because it's further to the left on the number line. But if I multiply by negative 1, or let's say I'm dividing by negative 1, just because we were dividing here, weren't we? So dividing will flip the signs here. I'll get 3 and 1. But can I say 3 is less than 1? Does it make sense for 3 to be less than 1? No, 3 is bigger than 1. So you see, that's why when we divide by negative number, doesn't matter whether it's -1 or -4, you have to flip the inequality, right? So that's what happened. Now this is exactly matching that line there. So you don't have to write this kind of proof for examiner. Examiner knows that when you divide it by -4, you have to flip inequality. So that makes sense. Let's look at another example. We went through part A already, so if you don't remember, look at the previous video. Now we're gonna prove part B. We work with part B. It says the linear line is tangent to the curve. We said when they say tangent, it means that there is only one intersection point. Okay, the curve on a graph has only one intersection point. What does that imply? It implies b squared minus 4ac is exactly 0. So we're gonna write what's the value of a, b, and c here. A is 2, b is negative 2k minus 1, and c is 3k minus 1. So we're gonna substitute those red values into this equation. We're gonna use the bracket here, minus 2. I'm gonna put it on the outside, actually, minus, factor a minus sign out, minus 2k plus 1, and I'm gonna put a square here. Now, that minus 1 that we factored out, it will be squared, so it will cancel away when you square it anyway. So, and then we got this 4 times 2 because a is 2, and value of c is 3k minus 1. Just writing what I've been given. And now let's expand this brackets and simplify this. Now when you expand this bracket here, we said we factor the minus 1 out, and minus 1 square is positive 1. So we write 4k squared plus another 4k plus 1. If you don't believe me, just work out 2k plus 1 times 2k plus 1 to yourself there. You get this expression here at the beginning. And then multiplying, let's just leave minus 4 alone. Just gonna multiply 2 into that bracket so I don't confuse myself with too many numbers at once. So now I am gonna multiply 4 into this bracket, so I'll get negative 24k more plus 8 because I would have made the sign error. Now I'm just gonna copy what's above and then simplify, collect like terms. Now here I'm gonna have 4k and minus 24k, and the rest, this double underlining is a constant with this double underlining. I can add them together. So 4k squared. What's this 4k minus 24? It's going to be minus 20k, and I will have a plus 9 there. Is that the same as the equation I was told? Yes. And now I'm checking. Now I'm seeing that they are true. Before that, there was no point looking at this answer and trying to manipulate the answer. Don't try to manipulate when you're being told to show that. Manipulate this. Right. You need to go back to the previous part of your question, have a think through what you've been given and work with the things you've been given. Every time you see a show that, yes, it's nice to check at the end, it will make sense. They're matching each other. So this is just to think to check your answer is correct. Alright? So good luck practicing. As if you had to actually find the value of k, we haven't been asked to solve it, but you would solve this quadratic equation